Alright, so in this video, I'm going to solve the equation 7 to the power of x plus 7 to the power of x plus 7 to the power of x is equal to 147. So to start, I'm going to factor out 7 to the power of x. So I get 7 to the power of x times 1 plus 1 plus 1 is equal to 147. So this is 7 to the power of x times 3 is equal to 147. Now from here, I'm going to divide both sides by 3. So 7 to the power of x is equal to 147 divided by 3 is going to equal 45. Sorry, not 45. 49. So I get 7 to the power of x is equal to 49, and 49 is equal to 7 squared. So I have 7 to the power of x is equal to 7 to the power of 2, meaning x is equal to 2. Alright, so in this video, I'm going to be solving the equation 7 to the power of x is equal to 70. So before we start on our solution, let's notice that this is an exponential equation, and x is an exponent, which is the variable we're solving for. So let's just try to plug in a number. Let's start with 1. So we have 7 to the power of 1, and this is equal to 7. Now, let's go one higher. Let's go 7 to the power of 2. This is equal to 49. And now let's go one higher. Let's go 7 to the power of 3. This is equal to 349. So notice how we're trying to find what value of x that we should take the power of 7 to equal 70. But even the number 3 results in a number much higher than 70, meaning the value of x is going to be a decimal somewhere in between 2 and 3. So now to actually solve for x, my equation is 7 to the power of x is equal to 70. And what I'm first going to do, and what I recommend doing for any exponential equation such as this, is taking the log on both sides. And the reason you should do this is because now you can use the property log a to the power of b. I can move this b to the front, so I get b times log a. Log a to the power of b is equal to b times log a. And the reason this property is so useful is because before, x was an exponent, and it's really hard to solve for x in its previous state. But now I can move x to the front, and it's going to be an actual term. So now I get x times log 7 is equal to log 70. Now, log 70 is the same thing as log of 7 times 10. And another property of logarithms is that if I have something in form log a times b, this is equal to log a plus log b. So log of 7 times 10 is going to equal log of 7 plus log of 10. So now from here, what I'm going to do is divide both sides by log 7, because we obviously want to isolate x, so the only way to do that is to get rid of this log 7. So then these two cancel out, and I get x is equal to log 7 plus log 10 over log 7. And I can rewrite this as log 7 over log 7 plus log 10 over log 7. Now log 7 and log 7 cancel out, so I get x is equal to 1 plus log 10 over log 7. And if you guys already didn't know, log 10 is actually equal to 1. So now I get x is equal to 1 plus 1 over log 7. And this is my answer.